Hey guys, today we're going to finish up lesson 2.2 in our Unit 1 Part 1 packets. So we're going to turn to our page on dot plots. For a dot plot, each data point is plotted using a dot above the horizontal axis. Each entry point should be equally spaced and about the same size. If you don't have them equally spaced or about the same size, you're going to create a situation where you can't read your graph. If you put one here and then a big one up there, it's going to look a lot different than if you have them all nicely done. This one on the left that I just drew, you can't see a lot from that, but the one on the right where they're all equally spaced, the same size, you can garner information from that. So right here we are going to take our information from our stem plot on the previous page and we're going to graph it on this dot plot. So our smallest number on the stem plot was 78. So that's the first place we'll put a dot, right here at 78. Then we have one at 105, one at 108, 3 at 109. If you guys want to pause here and go ahead and use that stem plot, that stem and leaf plot, to fill in the rest of your dot plot and then come back to check your answer. Okay, hopefully you got a chance to make your dot plot there. And here is what it should look like. I tried my best to make them equally spaced and the same size. When you're doing it by hand, there's going to be some errors, so you can see a couple are bigger than others. But you still get a pretty good idea of kind of what we're looking at. So let's look at a couple of the questions that this has. Number 3 asks, most of the data is clustered between what numbers? So you can see that most of the data is happening in between 105 and 135. That's where most of the data is clustered. That's not all of the data, but that's where a good portion of the data is clustered, kind of grouped together. Okay, what is the mode? If we remember, mode is the number that occurs the most. So if we look at our dot plot, we're going to look for that number where it has the highest amount of dots, and that would be 126. And then are there any outliers, any unusual points, any numbers that are far away from the data? We look there, 78 is definitely a good distance away from the rest of our data. And then on the next 2 pages, we have some check for understanding. So this first one, it talks about the Pew Research Center and asks a random sample of 517 18 to 34-year-olds what type of phone they use. So using this data, it wants you to make a bar chart, a bar graph, and a pie chart. So go ahead and pause the video here, take this and create your bar graph and pie chart, and then we'll take a look at it together. Okay, hopefully you guys got a chance to do your stem and leaf plot and your dot plot. I'll fix that 0 real quick. Okay, so when you counted out the presidents, it was very soon obvious that most presidents took office when they were 50. So this created a very long leaf for the 50s. So if you wanted to, you could have broke this into that split stem that we talked about last class, where 0 through 4 is on that top stem and 5 through 9 is in the bottom stem. But either way it works, you're just going to have a long leaf for the 50s. Here it can show that 40 and 60 have about the same, 50 has that most, 70s has that least. When you're making a stem and leaf plot, you want to try your best to kind of create columns so that everything kind of lines up so that you can see that data. It's not always going to be perfect when you do it by hand, but just do your best there. And then here's our dot plot. You can see that most of that data is right here in between like 46 and what's that, 58? And then we have another little cluster right here. You also might notice that we have some areas where there are no data. We're going to talk more about those next class, but those are called gaps. And then I don't think that these 2 dots here or these 3 over there are far away and are far enough from the data to be considered outliers, but that's that concept of outliers, is they're far away from the data. Okay, our last activity is called the misleading graph activity. So misleading graphs is a statistical graph that is not drawn appropriately. This type of graph can be misrepresented data and lead to false conclusions. For the following graphs, A, explain why the graph is misleading, and B, redraw the graph so that it is not misleading. So let's look at our first graph. So pause the video and decide what you think is misleading about this graph, and then come back and we'll talk about it. Okay, hopefully you got a chance to look at it and decide what you thought was misleading. What's misleading here is that the y-axis of our graph does not start at 0. That gives you, it kind of skews the data on where it's at. So I want you to take a minute, pause here, redraw the graph so that the y-axis does start at 0. Okay, hopefully you got a chance to draw your graph. When we start our y-axis at 0, it doesn't quite look as if there's such a big discrepancy between that high school and college and middle school. You see that they're much more equally matched, and the high school and the college looked so small, but you can see when you start your y-axis at 0 that they don't look as small. Okay, take a look at this next graph. Go ahead and pause here and decide what you think the misleading part of this graph is. Okay, hopefully you got a chance to decide what you thought the misleading part was. It's that the barrels are not the same size. That makes the right side, the non-OPEC countries, it makes it look like it's so much more than the OPEC countries, when in reality, they're not that far off on the y-axis. So let's go ahead and redraw our graph real quick. So our y-axis will stay the same. Go 500, 1,000, 1,500, 2,000. And we'll have OPEC and non-OPEC. And so we'll draw them to the same spots, and we will make them the same widths. And when you draw it this way, now they look a lot more comparable.